Change is a problem, and I'm sure you've all had to deal with it. A system, a feature, a piece of functionality that's had to change over time. Particularly if you're building an asynchronous system, an event-driven system, a system that uses messaging, change can be really tricky. Because you've got producers producing events, consumers consuming events, and these two things don't really know that each other exists. So if you as a producer need to deal with change your event in some way, how do you deal with that when you could potentially break 10 different systems that you don't even know exists? That's exactly the problem we're going to solve by the end of this video. Let's get to it. And the place to start whenever you are building any kind of event-driven system is in the code itself, how you actually design the events you publish. And the simplest way to think about that is to adopt some kind of defined specification for your events, something like the cloud event specification. Now, this isn't the only way to design your events, but it's quickly becoming the de facto standard for how to structure any messages you publish in an asynchronous system. And just to really quickly run through the different fields here, you've got the data property. This is the actual contents of the event. This is the bit of the event that will be different for all the different types of events that you publish across your system. This is what you might have traditionally simply published straight to your message broker. You've then got the data content type. This tells a consumer what type of information is in that data property. If it's JSON, it could be XML, it could be binary, it could be some weird internal format that you developed yourselves in-house. You've got the time the event was published. This is the time according to the producer, and some kind of unique identifier. This unique identifier helps downstream systems implement things like idempotency. Have I seen this event before? Yes, I have. I can forget about that. And then finally, when it comes to this conversation around versioning, around dealing with change, you've got the source and the type up at the top here. The source tells the consumer where did this event come from, and the type tells the consumer what type of event this is. In this case, it's an order-created event that came from the production order system. Now, you'll notice, really importantly, on the end of that type, there is a version number. This tells the consumer what version of structure is inside that data property. This is what will make it more easy for you to deal with change if you need to change the structure of your events. Let's have a look at what that might look like in practice. So imagine for a second you've got this loyalty points added event. This is an event that you publish whenever the loyalty points for a given user changes. You're a developer on the loyalty point service in this scenario. And you actually need to change the structure of the event now. There's a new requirement inside your bigger system to not just tell people the total points that this user now has, but also to tell people what the difference is, what the change was when this event was published. The first thing you would do in this instance is to create a brand new data type. We've got this loyalty points added v1. We will create loyalty points added v2. Don't worry about the fact this is all TypeScript. You can apply these same concepts to whatever programming language you're using. So you'll notice we've already now got this total point property now, difference, and user ID. And if we compare these two things, they're very, very different. If you were to make this change, implement it, ship it, you would probably break a whole bunch of downstream systems because the structure of the event, aside from the user ID, has fundamentally changed. So how would you deal with this as a producer? If I actually open up the code now that deals with the actual publishing of events, and if we scroll down through here, we've got this publish loyalty points updated function. Currently, this takes a loyalty points added v2 event. So when you've added that new data type, the code that actually publishes the event has also been updated to support that new data type. But you'll notice what you do inside here is the first thing you'll do is actually create a new instance of your loyalty points added v1 event. So you're going to create that old version of the event, and you're going to publish that as well. For a period of time, you're going to publish two versions of the same event. This allows you to evolve whilst also giving your downstream consumers flexibility as well. So if you have a look at this now, what we're doing is creating a new event ID. We're creating just a new unique identifier, and then we're creating two new cloud events. Most modern programming languages have an SDK for cloud events now. This is what we're using here in TypeScript. So I'm setting all the properties that you might accept, the type, the source, the data content type, the actual contents. But I'm also setting the same ID for both the version 1 cloud event and the version 2 cloud event. This is important because technically these are the same event. It's just two different structures of the same event. This makes things a little bit easier for your downstream consumers because if they receive both of these events, they might process the version 1 instance, receive version 2, check the ID, they've seen that before, drop that and not worry about processing it. The other thing that I've added here is this depreciation date property. Now, inside the cloud event specification, there's this concept of extension attributes. So there's a standard set of attributes that all cloud events should have, but there's also this idea of extensions where you can add custom attributes to support different fields that you might want to send in your events. So here I'm using an extension attribute called depreciation date. Inside that version 1 event that I publish, I'm setting the depreciation date to be the end of November this year. I'm recording this in October 2025. And then further down in this code, I'm then publishing both versions of the event. This happens to use Amazon EventBridge. It largely doesn't matter which messaging provider you're using. I'm just publishing both of these events now onto Amazon EventBridge. So as a producer, that's how you should think about things. When you need to make these breaking changes for a period of time, publish two versions of the same event, give them the same event ID because technically they are the same thing. Over time, you will then eventually depreciate version 1 of the event. And that's really, really important to set a depreciation date and make sure that you stick to it. Do not let that date slip. What you don't want to end up doing is supporting 15 different versions of the same event. So that covers how you might handle things as a producer. What about at the consumer side? So inside this same loyalty point code base, we actually also have this scenario where we're receiving multiple versions of the same event. There's a bunch of Lambda functions here that handle various different pieces of functionality. We have got this handle order completed function. Whenever an order gets completed inside the wider system, we want to react to that and increase the loyalty points that a given user has. And actually, the order completed event has gone through a couple of iterations. Version 1 of the order completed event looks something like this. It had an order number and a user ID. But the version 2, the order service, for whatever reason, changed that order number to be called order ID. Not so helpful for us, potentially breaks our system. So if we go and have a look at this actual Lambda function, this handle order completed Lambda function. And we scroll down through here, this is hooked up to an SQS queue. The events get published onto Amazon EventBridge, from EventBridge into an SQS queue, and then we iterate over the messages in the queue. And you'll notice what we're doing here, we're using them semantic conventions that we talked about in the last video in this series. And then we've also got this very simple if statement down at the bottom here. We're saying if the type property inside that cloud event specification contains v1, then we're mapping that order completed event v1 into this update points command handler. We've got a ports and adapters style of structure in the code base here. So inside our Lambda function code here, all you're doing is adapting that inbound event payload into your structure for your internal business logic. This is kind of beneficial because now you know anywhere in your code base where you're handling multiple versions of the events is going to be in this code base here. And the one thing we could do actually to make this a little bit more robust is we could actually tag our messages. So if we go into this v1 handler here, and if I jump to the end and jump underneath here, I'm actually going to take my message processing span and I'm going to set a tag on this message processing span saying depreciated message, and I'm just going to set that to true in this instance. So now inside your observability backend, you can now actually start to query your observability data. You can say, show me all of the spans that are tagged with depreciated message true, because we know that this version 1 event has been depreciated. If I wanted to take this one step further, you could use that depreciation date inside the event that you publish to actually set a property here or increment a metric to say we are this many days from a depreciated message. So combining things like the cloud event specification, combining that really defined structure for how you publish your events, including version information in your events, as a producer producing two versions, as a consumer, making sure you handle them two versions, but using your telemetry to indicate to you when you might have an event coming up that is going to be depreciated. Now, of course, this won't absolutely guarantee that you can easily evolve your systems whenever you want. You will still have challenges. There are still potential issues that come from this approach. But adopting things like a cloud event specification, adopting the ability to version your events, and having practices in place to allow you to handle these multiple versions seamlessly will make things easier. If you've liked this series of videos, please like and subscribe to the channel. If you're not familiar with this new Datadog community YouTube channel, this is going to be covering a whole range of different tech topics that matter to you. Practitioners, people actually have fingers on keyboard building real systems. I'll see you in the next one.